presentations. And I first the honor to introduce you Ankel Borja, our keynote speaker for this session. His career has really focused on translating the marine ecology research for improving the monitoring and the assessment of our marine environment and under the different European environmental directives. He published 100 papers about this, which are highly cited, and he has also advised a lot of scientists and policymakers worldwide on this ecosystem health issue. So therefore, I'm sure he will give us a good overview on this theme and give us some inspiring thoughts about this topic. So thank you, Angel, and the floor is to you to present the next 15 minutes.
Thank you, Gert. Good afternoon, everyone. It is a pleasure to be here, and thank you to the organizers for inviting me to give this plenary talk about assessing the ocean health status using multiple indicators. I think that all of you are aware about the management of the seas related with this framework, which is the Deepside framework, in which you have different driving forces, which are usually socioeconomic forces that can give place to human activities. And then, for example, could be the trading or the shipping of the goods and services across the seas. This could be the commerce, could be the driving forces doing this activity. And these activities can produce pressures at sea. For example, in this particular case of shipping, could be the ballast waters when they arrive to the port and they release these ballast waters. And these pressures can produce changes in the state of the system. In this particular case, the change could be change in the composition of the species, in the local composition of the species, because introducing the ballast waters are introducing some alien species or some non-indigenous species. And this change in the state can produce impacts at the sea. For example, this introduction of non-indigenous species or invasive species that can cause harm to the ecosystem services and to the environment. For example, can cause harm in the aquaculture or fishing or even in the environment. And when this happens, we need to respond in some way to this. And usually these responses could be legislation. For example, the Convention of Ballast Waters in order to reduce this problem. But other responses could be also technological or ocean literacy responses, etc. There are many different measures that can be taken in order to act on the driving forces, on the pressures, and on the change of the state in order to reduce the impacts. One example when doing this management of the seas in Europe, you know very well, is the Marine Strategy Framework Directive, in which we have to monitor and assess 11 qualitative descriptors covering from biodiversity, for example, biodiversity, alien species, food webs, or seafloor integrity, but also some different pressures, human pressures. Of course, fishing is an important pressure, but other could be eutrophication, pollution in the water, in the sediments, in the biomonitors, but also pollution in the seafood, as well as litter and introduction of energy and noise. And of course, we need to take into account the hydrography or change in the hydrography due to the human activities or the human pressures. In order to complicate even more this, you know that for biodiversity, we can monitor plenty of different ecosystem components from the microbes to the cetaceans, going through the whole taxonomical range from fish, macroalgae, macroinvertebrates, seabirds, etc. And for all of these issues that we need to monitor, we can have hundreds of indicators. And the problem of this is how to deal with this, how to assess the status of marine waters with these hundreds of indicators. For doing this, we monitor using different methodologies, from satellites to directly taken samples from the sea, and also from different ecosystem components, as commented before, in order to finally studying all this bulk of data, obtain a result on the status of the sea. The problem is to integrate all this information. For doing this, there are many or hundreds or thousands of different methodologies to integrate this information. But the main problem is to deal with this question: what is good environmental status, or what is good health of the system, and how we know if we have reached or attained it. And for doing this, we need to apply something like the ecosystem-based approach, in which we take into account all the ecosystem components, all the matrices, all the information we have. And the problem is how to deal with this. For doing this, there are several methodologies. A few years ago, we did a review of the few methodologies able to do the ecosystem approach in the practice. And in a European project, which was the BOTS, we developed this method, which is the NEAT, the Nested Environmental Status Assessment Tool, in which we are able to bring together different ecosystem components and hundreds of indicators. What is NEAT is a software which is designed to perform environmental assessments. It is based on indicators, and the indicators are used to make an integrative assessment. Each indicator is based on a spatial assessment unit, so we need to assign each indicator to a spatial assessment units. It gives information on the confidence or the uncertainty of the information, and it is necessary to assess the marine ecosystem in an integrative way. So this is related with the ecosystem-based approach. As commented before, it's based on indicators. And an indicator is any quantitative parameter that represents the state of the ecosystem. And we need the observed value. In this example, this is the Secchi depth in an estuary or at sea. And we have the measured value, but also we need the targets, what is good and not good. In this particular case, we can put this threshold in which below this is a good status and above this is in not good status. And the issue is to relate the observed value with the threshold, and we call this the ecological quality ratio. But then when you need, if you want to integrate hundreds of indicators, you need to harmonize this, to normalize this, because think about this image in which you have two indicators, one ranking from 25 to more than 800 with these different thresholds, and this is the threshold between good and not good. And other indicator in which you have the opposite. The worst value is more than 180, and the best value is 0.1, and with different thresholds. So you need to normalize this in order to make each indicator in a range between 0 and 1, in both cases, and then the quality classes and the thresholds always between in 0.6. This is because then you can calculate everything with the different indicators if they are all normalized. The second issue is related with the spatial assessment units. So you need, if you are going to assess the status, for example, in these regional seas, a sea in which you have two parts, each part can have 50% of the weight. And if you have one indicator associated here and another associated here, each indicator has 50% of the final weight. But imagine that in this part you have one indicator, in this part you have 3 indicators, so the weighting is different. And then you can complicate even more because you can have different nesting distribution of the different spatial assessment units with indicators at different levels, and each of them will have a partial weight of the total amount. So you need to be cautious about the representativeness of the indicators. So it is not possible to have only a single indicator here and plenty of indicators here. Summarizing this, to integrate everything, each indicator, you can have hundreds of indicators. Each indicator should be assigned to one ecosystem component, one habitat, and one spatial assessment unit, as you can see here. And then the final value of need is calculated as a weighted mean of all the indicator values assigned to a certain spatial assessment unit or habitat or combination of both, and can be visualized as habitat by a spatial assessment unit or ecosystem component by a spatial assessment unit. And finally, you can get a value between 0, which is the worst situation, the worst status, 1, which is the best status, and if it is above 0.6, it will be in good status. If it is below, it will be in less than good status. This is a quick overview of the software, and which is a flexible tool for the calculation. It's both for Windows or Mac. It is free of charge in this web page. This is the main screen of the software, in which you can define the spatial assessment units, the habitats, the ecosystem components, and the indicators, and then you can do the assessment. And it's quite flexible because you can weight or not weight by spatial assessment unit, by habitat, by the descriptors from the MSFD, etc., etc. And you can configure the different options. Yes, I'm going to show you 2 examples. One is an application we did for the whole Europe, taking into account open access databases in order to show to the managers that it is possible with the current database or data availability to assess the status of the marine waters in Europe. We took the whole Europe with different parts in each of the regional seas, as you can see here. In each part of this, we have plenty of different fish data sets. In these points, green points, we have chlorophyll A information, and in these dots, we have contaminants. And for doing this, we have for fish, 2 indicators, fish mortality and spawning stock biomass for 341 stocks each, with this range of values and these thresholds taken from this literature. For eutrophication, we use the 19th percentile for chlorophyll A with different values for the different areas, taking into account the intercalibration done within the Water Framework Directive. And for the contaminants, we have 3 organic compounds and 3 metals, and the same taken from the Priority Substances Directive, the threshold values. And this is just the result for these few descriptors and relatively few indicators, but it doesn't matter about the final result, but it's just to show to the stakeholders and to the authorities that it is possible to do this at a huge scale, a large scale. And even more, you can see here for the different integration at the level of Europe, at the level of each of the regional seas, but then at the level of the subregions, you can get the information weighting by the size of the spatial assessment units or without weighting by the size of the spatial assessment units. and also the information for each ecosystem component, each habitat, and each descriptor in both cases, and you can compare and you can track where are the problems for which components, for in which areas, etc., etc. And the second example, very quickly, this was published 2 weeks ago or 3 weeks ago, is an example from Malta in which we took the official data they reported for the MSFD assessment, and we compare with the NEET assessment. In the case of Malta, they didn't assess the status in an integrative way, so simply they did for each indicator if it is in good or not good status, but without integration. This part of this smaller part of the table shows which number of indicators are in good status, in not good status, and not able to assess the status. And here is the number of indicators used within NEET, and this is the calculation. And you can see that we were able, in this particular case, for biodiversity, species, and for different criteria within the MSFD for birds, cetaceans, etc., we were able to assess the status at the simple level of each of the criterion and the level of the descriptor, and globally for Malta. So as conclusions, I think that we have already sophisticated tools allowing to integrate multiple data sources, scales, and indicators into a single assessment. NEET is a free software allowing to undertake such integrative assessments under the ecosystem-based approach. It has been validated in multiple environments, from shallow waters to deep sea systems, and also from coastal areas to open seas. It has been used in a range of areas from 500 square kilometers to several millions of square kilometers, from subregional seas to continental scales, and in different seas, from all the European seas, the Arctic, the Caspian Sea, and the Persian Gulf. And we have shown that NEET is flexible enough to accommodate any type of ecosystem assessments, for example, for the MSFD, but also we did for bathing waters, or to environmental impact assessment, or in protected areas, etc. And also we have demonstrated that NEET responds to managers and policymakers' requirements to take informed decisions on management and decide on measures to achieve healthy marine ecosystems. So that's all from my side. If there are questions, I'm happy to provide you any response. And I will make available this presentation in my ResearchGate profile if you want to download it. Thank you.
Thank you, Uncle Borja, to give us a view on this indeed complex process of